Let's just start with the perception of growth dynamics. The general perception is that cities are very dynamic entities and that they constantly evolve with time. And with this growth, travel times increase. But uh, over the last few decades, the world cities, the travel distance has increased and the commute times have remained oddly stable. So the rationale behind this occurrence must be looked into. And among the most convincing ideas to explain such an occurrence is the idea of travel time budgets. Uh, Travel time budgets are basically, an individual travel time budget is basically the computed sum of duration of all trips realized in a day. So the concept of travel time budgets has been researched into since the 1970s, and it is also known as the Marchetti's constant because he was the first person to actually come up with such a concept, and he came up with the concept of 1 hour wide cities. And this was further taken up by Yakov Zahavi in 1970s, where he proposed that this travel time budget is 1 hour, and this is a constant. It's 1 hour per day per capita. And his hypothesis also had a twofold constancy, so spatial and temporal. So travel time budgets is constant over different cities and over different time periods also. And this has also been explained as the strong and the weak hypothesis. So the stability of travel time budget at an aggregate level is the strong hypothesis, and the regularities of the relationships between travel time budgets and the variables at a disaggregate level has been explained as the weak hypothesis. There have been various researchers in support of this constant TTB concept, and each researcher has fixed this constant from 50 minutes to over 1.3 hours. So we can see that this travel time budget has been almost seen as a universal constant between 1 to 1.3 hours. You have researchers in support of constant TTB concept, and you have critiques of such a conjecture too. So the critiques of the Zahavi's conjecture have been concerned with the influence of other variables such as socioeconomic and activity related and area specific variables over travel time budgets. So some have found that some have a positive influence over travel time budgets and others negative. Some find significant relationships and some find no relationship at all. And if you see, you would find that what is positive or has been hypothesized as positive for one researcher is not so for another one. So what we can actually see is that these multiple critics are warnings to the abusive use of constant TTB concept in a non-world level, which is at a disaggregate level. So what is more important is that the level of observation and the application. So the stability hypothesis is at a world level, and the critiques suggest that at a disaggregate level it might not be true. And this research furthers from here. So here we've made two propositions. Proposition 1, while the travel time might vary by size of the city and over time, there are probably certain thresholds within which people would like to travel, the maximum and the minimum time. And proposition 2, that there are certain travelers who travel beyond these thresholds that we call them extreme travelers. And this research would look into who they are, why they do accept such conditions. So this study was carried out for the city of Chennai, actually the urban agglomeration of Chennai, for about 8.9 million population. And it was a household mobility survey for about 200 households, and for a mobile population of 533, 1,277 trips were captured. And this was followed by a couple of perception surveys also, and life story interviews. So basic observations that the mean travel time budget for the city of Chennai was 69.39, and a minimum of 4 and a maximum of 360 minutes. So a preliminary regression, a linear regression showed that the R-square value was pretty low, but still the classical variables that all the researchers have used, that was found to be significant. But this low R-square value was an indicator that the relationships that we assume linear are not linear actually. So there is a need for a multidimensional method to analyze travel time budgets. So duration modeling was taken up. Duration modeling can be better known as survival analysis in the field of medical research, and it's called duration modeling in economics and transport. So this duration modeling, it models the conditional probability of end of duration of a process. And this end of duration of a process is actually dependent on the time that has elapsed. And this probability can also vary during the process. And the estimation of this conditional probability is the hazard rate, so which will actually inform us about the dynamics of travel time budgets. And the data needed was basically a duration data that is non-negative and can be censored and is also time varying. So basically, we start off with the non-parametric method, the life table and the Kaplan-Meier method, which basically helps us to explore the covariance effects. So here we find the survival curve. So it was interesting to find that the survival curve had two inflection points. The first one near 25 minutes and the second one at 125 minutes. This is an indicative, it's indicative of the existence of a minimum travel time budget probably at 25 minutes, and at 125 minutes is the next inflection over which the survival curve, the probability diminishes. So we can look at 125 minutes as the maximum threshold. And the hazard curve has a characteristic peak at 150, 225, and 275 minutes. And it was interesting to see that the hazard has been increasing till 50 minutes, and then it decreases. This is the median survival lifetime. We would be able to see that the median survival is constant between 20 and 40 minutes, and has been seen to increase till around 60 minutes, and then it starts decreasing. The Kaplan-Meier survival curves help us to understand the relationships between travel time budgets and the considered variables. So here are household size, gender, purpose, and income. So we find that for household size and purpose, the survival function is not significantly different between the categories. While for gender and income, the survival functions are significantly different between the categories. Same way with age, mode, and children, households having children below 10 years, and number of vehicles, survival functions seem to be significantly different between the categories. And professional status, the survival function is not significantly different between categories. It was important to actually understand that the life table and the Kaplan-Meier tests are, again, unidimensional, and the intuition given by these tests, again, further need to be examined, and which is why a semi-parametric method was used. And it also helps us to identify the influential variables. So this was the Cox proportional hazard model. So you would find 3 sets which were examined based on, it is a selective method. So we find that a couple of household and individual characteristics and the purpose and principal mode. So all of these things exhibit a positive relationship with the travel time budgets. The effective variables on travel time budgets. So males have a lower hazard and a higher travel time budget, and the travel time budget increased with age. Workers have a higher travel time budget, and the presence of children below 10 years of age decreases the travel time budget of the members in the house. The number of working household members is actually positively linked to the travel time budget, and higher household income members have a higher travel time budget. And modes of transport have both high and low hazard ratios, and in the order of increasing the travel time budget, it's walking, bicycle, motorcycle, car, and public transport. The semi-parametric method confirmed the intuitions of non-parametric approach, and has helped in selection of the influential variables. But it is not possible to go to the duration dependence concept from it. So we need to move on to a fully parametric model, wherein we'll have to identify the apt distribution forms. So this is an accelerated lifetime model, and the goodness of fit was checked, and the log normal distribution had the best goodness of fit. So that was taken up for the parametric estimation, and it was found that the worker had a higher TTB. Household responsibilities represented by the number of children leads to lower TTB, and the number of household members increased the travel time budget. The individuals characterized by high household income have a higher TTB, and these basically confirmed the intuitions that the other methods suggested. So this was one of the most interesting part of the finding. So this is the hazard curve, and you would find that it's a non-monotonic and inverted U shaped hazard, with an inflection point at 75 minutes. So if the travel time constancy hypothesis or stability hypothesis were true, you would probably expect a monotonically increasing curve here, but you don't find that here. What you find is that until 75 minutes, you probably find a minimization mechanism working. Over 75 minutes, you don't see that. This probably tells us that this entire population that we're studying about is probably made out of two different groups of people. One who are able to use the minimization mechanism, and another group who cannot or do not want to do so. So these probably are the extreme travelers that we are talking about. So extreme travelers in the study are defined as the individuals who travel beyond 125 minutes. So it was important to profile the extreme travelers. So extreme travel is observed more in work trips than educational trips, and at least in the case of Chennai, it was found that an extreme traveler is mostly a male worker who commutes excessively to work, or it is a student going to his institution using private or public mode. And how different are these extreme travelers from the normal travelers? There is actually no statistically significant difference between the means when it comes to age, and income and vehicles owned, there is a difference. Does the extreme traveler show different preferences? So it was important that the interviews also had a couple of questions regarding important factors they used to choose. They used to choose the mode of travel to work, and it can be seen that excess travelers' value of good accessibility is actually significantly different, and it's more when compared to the non-excess travelers. And making use of travel time as a rationale for intensive traveling. It was found that extreme traveling falls somewhere between life choices, which is family, residential, and a career choice, and determinants were residential anchorage, social anchorage, and a pursuit of a career. And it was found that excess travelers feel more negative about the travel to work than the whole sample, and significant difference of means between excess and non-excess travelers, finding a quicker and cheaper way to travel, and the relaxing and boring nature of travel. And excess travelers have a higher mean score on for the question, if I could find a quicker and cheaper way, I would use it, which suggests that not all excess travelers are excess travelers by choice. And it was interesting to also note the sort of activities they did while they traveled. This is one respondent who says that he listens to music, observes, eats, There's another person who says he thinks, talks, and observes. And so what is this perception of travel time among the extreme travelers? So we were able to group it into 3 groups. One who go by activity optimization. They optimize their travel time by doing activities during the trip that they probably wouldn't do at another time. And some see travel time as an additional time. And the others who see travel time as a time to kill. They find it useless. So while the sample size of this study is small, but then it has a significant contribution by confirming that the excess traveling exists among commuters. And it also gives an understanding between differences between the excess and the non-excess travelers and their perceptions of travel time itself. And a better way of understanding the excess travelers and why and how they behave is very important to exploring policy to encourage sustainable transport patterns of commuting. And I would just take a minute. So I made the statement saying the commute times have remained oddly stable, but one cannot ignore the fact that transport-related decisions that have been made also instill this stability that we are talking about. Thank you.